All right, this week on Kumulus on Cloud, I'm going to tackle one of my favorite topics of all time, serverless computing. So I've gone on record many times in saying serverless computing is ridiculous because it's not really serverless. Then, and in reality, it's a little bit tongue in cheek because serverless actually has a really interesting use. I think the better name for it is actually function as a service, and that's a different version of the platform as a service model. The interesting thing to me is that function as a service is not something that stands alone on its own. Function as a service is a model by which you're effectively using events to trigger application resources. Now, in general, most of the cloud-based function as a service offerings often have a lower overhead or compute cost overhead because the function is only launched when it's actually needed. Now, that doesn't mean that the underlying resources aren't turned on and run for a long period of time, but most of the vendor provided, so the Amazons and Azures and Google, etc., provided function as a service models often focus on the function being the running aspect rather than the underlying, often containerized resource that's actually providing that function. So deploying a container and only triggering the process within that container when you need it means that, yes, I might have consumed some resource or at least define an allocation of some resource, but a container that isn't actually running the process and just lives there live on the system isn't actually using much except for disk resource. And often functions are the most compact of containers. Functions can be very small, on the order of 10, 20, 30 megabytes in size, almost too small for a service provider to charge for the disk space being consumed. I think this is one of the reasons that the function as a service model tends to focus on CPU cycle time and memory consumed when the function is running as the model for costing of those resources. Now, that model has driven a lot of companies to look at how they implement function as a service as a part of their cloud strategy because there's a potential huge cost savings and benefit to this. And if your application development staff has already been working in the function as a service kind of, or rather function as development space, classically these are tools like writing Node.js applications as an example, because you're writing a function as the way of actually managing the compute resources that you're doing. You're dealing with a set of functions that are effectively driven by events already. It's actually fairly straightforward to look at taking those applications and moving them into function as a service or serverless types of systems models. Now, there is another piece to the puzzle, and that is that you have to now look at the application not just being those functions, but also the entire event stream that drives the execution of those functions. When is there an event that shows up? What is that event that is triggering that function? Is it an API gateway-based service where I have another application that is providing, for example, a RESTful API, and when the right API request comes in, the function gets spun up to execute a task and then return a response, and then the function gets shut down again. The API basically goes back to sleep as well, waiting for the next API request to come in. Often the services sort of go hand in hand, so you'll see people talking about using the Amazon API gateway service in conjunction with the Lambda serverless function-based model. This is true for any of the other cloud providers as well, is that this is a fairly common model. Another approach is to use something like an object store as the triggering mechanism for those functions, and actually leveraging that as a way of implementing the function or triggering the function to go do something, consume the resources that were stored in that S3 bucket, and then potentially write back to a separate S3 bucket, which may create another event. And that event might be a response back to the end user, again, through another functional service, or it might be an API response that then actually responds something back to the end user as well. So there are lots of processes involved, but now we realize that it's not just about the function. So serverless isn't just about that one little function that's written, but it's about the process by which that function gets consumed across all of those API and event-based boundaries. And so when we're thinking about migrating applications into the cloud, and we've looked at VMs and said, well, that's not the appropriate resource, and we've looked at potentially migrating to cloud-native models or potentially even microservice-based models for applications and said, well, that still is a step in the right direction, but it still is very heavyweight approach to taking on my application problems. And if we've already been writing our applications as functional services anyway, it might be possible to go directly to a serverless model for some of those applications. Those rewrites, depending again on the development staff that's already in place, might be straightforward. It might be that they actually even find this even more interesting in terms of how they're developing their applications than the static models that they'd been using in the past with basic Node.js components. I think one of the most interesting things is that most of the function as a service tools use Node as their default language for how those functions get written. Now, technically, you can write a function in any language that takes a set of inputs or has a way of taking inputs, doing some processing, and giving out a set of outputs, because that's all that the functions are really doing. But it turns out that because of the evented model that most people are working with inside of a Node.js type server application, that's already sort of tuned into the serverless framework model for interacting with all these other services and getting service events in that are actually triggering functions. So we see the two work fairly well together. And it's, again, another way of thinking about how your applications come together. Now, I'd be remiss if I didn't also touch on security when we were thinking about this in terms of our overall migration strategy. And the security here now comes down not only to understanding what libraries might have been called into building out that function and sort of dealing with the CVEs that might be posted against those libraries. Often those functions themselves are containerized. If they are truly containerized functions in the classic container systems model, then we can leverage the registry dynamic and static checking kinds of capabilities to keep those systems up to date and secure. But there are plenty of functions that are not using that model. Instead, they're just bundling up the application as a tarball, which is or a zip file, basically a compressed archive of our resources, which means that we have to look at how those are being stored, and is there a way to actually statically check those resources as well. Now, it might just be that we have to understand what went into that library in advance and keep a separate track of any CVEs that might come against those particular libraries. A little trickier. There's no automation that I've seen currently to support that, but certainly is something that could be done as a part of the development process, and basically just make sure that you're doing maybe a development cycle every single day, even if nothing has changed, just to do library checks as an example. But that's one piece of the puzzle. Making sure that your application code is secure is always an important aspect of anything that you're moving into or building for the cloud specifically. In addition, now, again, since this is an evented model, we have to look at what it is that's generating those events, and are we securing those resources appropriately? So am I using an API gateway? And if I am, how am I securing that gateway? Do I have the appropriate authentication engines in place to make sure that only the right end users, be they internal or customer facing, can actually get access to those resources? If I have something like an S3 bucket as a triggering point, what does it take to get something into that S3 bucket? How do I deal with that security path and flow? And of course, the response also has to be looked at from a security perspective. How do I know how I am releasing this code back to my end users? Am I making sure that I'm using security tokens that can only be used one time, for example, to retrieve something out of a storage environment, or even an API based interface? Is a very important aspect to keeping that entire environment secure. Because again, while the focus has become on the actual function that's doing the work, we can't forget about the rest of the application that still needs to be secured, still needs to be connected between all these different resources and components. So serverless, I think, can be a very powerful tool. Really, function as a service is the term I like much better for that, but it's not standalone. We have to think about the other resources that come into play as well. Well, folks, thanks for watching. If you liked it, don't forget to like it. Hit that thumbs up button. We always like to know that we're doing a good job. Don't forget to share this with your friends, and just to make sure that you get the latest and greatest episodes that we release, hit that subscribe button, and don't forget to hit the little bell next to it so that you actually can get notified when they come out. Thanks so much for joining us.